we are going to be using the x and y intercepts. Now, the y-intercept is particularly important because you're going to use that a lot when you're doing slope-intercept form. Okay? But again, the y-intercept is that point where it crosses the x-axis. And of course, the y-intercept is again that point where it crosses the y-axis. Okay, so that's the definition of the x-intercept and the y-intercept. Now, if I show you a graph and I ask you to indicate to me what the x and y intercepts are, where does that graph cross the x-axis?
At -2.
At -2. And so somebody is going to say to me, the x-intercept is -2. Okay? And when I grade your paper, I'm going to go, no.
What?
It's not. Okay? And let me tell you the reason why. This is why it's important. Because you have to tell me that where that line crosses the x-axis is a point. What is the ordered pair for this point?
-2, 0.
-2, 0.
So that's the one.
So that's the x-intercept. What's the y-intercept?
1, 0.
0, 1.
Oh.
Okay? That's the y-intercept right there. Okay? So notice that anywhere along this x-axis, my y value is always 0. Anywhere along the y-axis, my x value is always 0. That's going to become very important in just a little bit. So, then we go to an equation. Okay? Now there's going to be two ways that we're going to look at doing this. The first way is to say, okay, if I am looking for my x-intercept, okay, anywhere along this x-axis, what's the value of my y? 0. So if I'm looking for my x-intercept, my y value is 0. I should work that better. My y value is 0. Okay? Well, -2 times 0 is 0, so we have 5x equals 10, so x equals 2. So my x-intercept is 2, 0. If I do the y-intercept, anywhere along this y-axis, my x value is 0. So we plug in 0 for x, and we have -2y equals 10. Y equals -5. So my y-intercept is 0. X is 0, -5. So then we graph them. X-intercept, 2, 0. Y-intercept, 0, -5. Sorry.
So the variables are always going to be worth 0? So like if I'm looking for x-intercept, y is always going to be worth 0?
That's correct. Okay? Now, let's go over a slightly easier way of doing this. Okay? And it's kind of simply known as cover-up method. Okay? If I want the x-intercept, cover up the y. Okay? Let's just cover up the y. Alright? And so then we can clearly see that 5x equals 10, so x is going to equal 2. Alright? If we want to find the y-intercept, well, we'll just cover up the x. That's all for y. Does that make sense? Yes. Okay, good. All right, so, Jack, what's my y-intercept?
0. I don't understand.
Oh my gosh. Aiden? Huh? 4's up here. It intersects right there.
I can't see from Leo's orange.
Wait, is it?
You should have known the infinite first.
Dennis? Huh?
04.
No.
0.
I mean,
EJ.
I mean 03.
0, 3. Okay, good. All right, so my y-intercept is 0, 3. Okay? EJ, what's the x-intercept going to be?
0.
Eh.
Wait, no.
Let me do it, please.
It's -2, 1,
Uh-uh.
1, -2.
-2, and the y is always 0. Okay. All right.
I want to answer it.
So, 0, 3, -2, 0. Okay? All right, so, on the back of that sheet of paper, I want you to give me the x and y intercepts for this equation. We are looking for the x-intercept. What did you get?
I didn't even get halfway to the problem. I don't know.
EJ, what you got?
I got 5, 0.
No? Close.
For x,
Yeah, we have 4x equals 16.
oh wait, it's 4.
4. So we have 4, 0. Okay? Leo, what's the y-intercept?
08.
0, 8. All right, so you can either graph all of them at one time or you can do them separately. I'm doing the first one. Just look at it. Don't even do the work. Okay? Don't even do the work.
I'm gonna do the work.
Jason,
What? The chat.
look at this. What's the x-intercept for this?
I was doing the other one.
I want you to do this one. What's the x-intercept? 7, 0. Okay? Aiden, what's the y-intercept?
0.
No. Close. But if you cover up the x, you have -7y equals 21. So you divide the -7 and y equals -3. So we plot 7, 0, 0, -3. We graph the line. All right? You guys graph the next 3 functions on that sheet of paper that I handed out. Jack, if I cover up the x.
Is it 4?
Oh, there you go. Fun it. So the y-intercept is 0, 4. Okay, now this one's a little bit tricky because, again, you have to cover up or plug in 0 for y for the x.
What?
Okay? So therefore, if I'm solving for the y, I have 0 equals -x plus 4.
It said that.
Now, again, all you got to do is solve for this. How am I going to solve for this?
It's 0. On time, I'll be doing this.
Huh?
On time, I'll be doing this. X equals 0.
No. How do I solve for this?
Dang. Oh, you subtract 4?
If I could just move this x over right here. Okay? So x equals 4. So therefore my x-intercept is 4, 0. So I graph them, 0, 4, 4, 0. There's my line. All right. Do the next one.
Yep. Oh,
Oh my god. You go too fast.
Jack, you go too slow.
Exactly.
Come on.
Jackson got it.
I do. You know what?
I've been at that.
See, she's calling you Chasten too now. Ah,
Chasing. It's Jack.
She's
Jason.
calling me that.
wait. Now I'm confused.
Chasten.
Fast.
C-H-A-S-T.
Can't see it now.
I'm gonna try to put the J in front of that. I just call you Jason now.
Jason.
I like it. You get to have fun doing that.
This is the fun.
Jack, you know I'm coming after you for this, so put that pencil to work. Put that pencil to work.
Why do you always
Oh,
have
God. Get this to work, wow.
You got answers formulation? Okay. I'm gonna let you have one. But Jack's don't get the other.
Alright, hold on. Give me a second.
We're gonna put your face behind that big black one right there. We ain't gotta see it. Jack, it's up there.
Okay, yeah, I know. Okay.